recording. Start the webinar, let people flow in. 1, 2, 3. Welcome, Digital Roundtable, Wednesday, April 28th. We are on. We have another glorious day in paradise and things are ready to rumble. We have a great guest for you all today. So hold on to your seatbelts and tie them tight. And let's go for some spinning around on music. Dr. John Sibley Butler. Wow, John, that's very nice. Thank you, sir.
Thank you very much.
I appreciate that. You know, I have a little bit of German blood myself. So how are you doing today, John?
Everything is fine. We're looking at everything that's happening around. We have some kind of optimistic future we're looking at. People are coming out and talking about getting rid, quote, of their mask. I think the economy itself is pretty interesting. So it's a great day in Austin, Texas. The weather is just right. And my big thing now is getting through the finals with my great undergraduate students in my technology transfer class at the University of Texas at Austin. But it's a great day in Austin, Texas. And I love that AGC that you have on.
Yes, sir. Yes, sir. Thank you. Llewelyn, how are you doing today?
Very well, thank you, Andres. All is quite excellent. I'm in Washington, D.C. today. I'm bringing this to you from the hotel room at the Holiday Inn downtown.
Excellent. Excellent. For all those listening, we call anything outside of our borders either East, North, South, or West Texas. So Llewelyn today is in East Texas.
This is the most Texas-centric program on television.
That's right. And we have a great guest today. And so, you know, let's say hello to Arshad Mansoor. Arshad, how are you today? Where are you?
I am doing fine. Thank you. Thank you. I'm in East Texas as well, in DC, in our office, actually, in our EPRI office in Washington, DC.
Fantastic. Fantastic. Well, thanks for being with us. And we look forward to having you and listening to your wisdom and insights. So let me introduce you for all those that are just tuning in. Arshad Mansoor is the President and Chief Executive Officer of EPRI. EPRI is the Electric Power Research Institute, and EPRI provides through leadership, industry expertise, and collaborative value to help the electricity sector identify issues, technology gaps, and broader needs that can be addressed through effective research and development programs for the benefit of society. It's a great institution. Those of us in the industry that know EPRI have great regards for EPRI and their thought leadership and in contribution on every aspect of the industry. Arshad in particular, it's a well-schooled human being. He completed an advanced executive management program at Harvard Business School, and he holds a PhD and master's degrees in electrical engineering from the University of Texas at Austin. Oh, wow, a Longhorn. And then he holds a Bachelor of Science in Electrical Engineering from Bangladesh University of Engineering and Technology. So welcome again, Arshad. Happy to have you.
Thank you. It's my pleasure.
Okay. So let's get rolling here on where we are, gentlemen, and looking forward to your take. Seems like COVID is settling down. Again, one loss is too many losses. Too many families have been impacted. Very sad for all that. But we seem to be taming the monster, if you will. The vaccination programs, it's rampant. There are 232 million folks that have been vaccinated so far. And obviously some folks don't want to be vaccinated. That is their right. Nevertheless, it seems like, you know, the economy in general and things are settling down in many ways, looking up into the future, you know, a year from now, 2 years from now, great predictions of growth. So Arshad, I'm curious, you know, COVID, I'm sure has been an interesting twist and challenge to the industry. I wonder if there are any lessons learned or interesting nuances that you can share with us about the impact of COVID in the power industry, and what have you seen as solutions, or what have you guys done in anything to help with solutions in terms of dealing with the challenge?
Well, no, thank you. And yes, COVID situation is getting better and better in the US, but we will only get rid of this when the world is in the same place. Unfortunately, the world is not. In places like Brazil, India, it is just going up through the roof. So our thoughts and prayers for all the folks who have been impacted by COVID. So we have, I think, I'd say 3 main learnings that we saw, and it's evolving because we still are in the middle of the COVID. I think the first was not just the electric sector, but we talk about resiliency and adaptability. Humans are actually very resilient and very adaptable. I mean, look at what retail industries have done in 2 months, which could be a 4-year IT project to get it done. And the electric sector has done the same. They've figured out how to keep the lights on, how to keep the customers happy, and do that while not coming to the office. And I think that's a testament to human resiliency and adaptability that we're seeing.
Mm-hmm. Absolutely. It's similarly, you know, I wanted to get your take and then switch to the guys. It seems like the economy, it's, you know, there was a bit of a, you know, expectations, you know, in the transition of government where things were going to go, and then all of a sudden things pick up again. And now we have a, you know, a stimulus package that is gigantic, you know, after the 1.9, you know, on the 2.3 trillion package that hasn't been approved, but hopefully it'll get forward. What's your take on you know, what does the economy look like in the power sector? What are utilities feeling? Are they buying? Are they frozen? What's the psyche? What's the context today?
Well, I think the psyche, you know, the electric sector has fared better than many other sectors like service sectors. Electricity is a societal universal need. The load is shifting. Residential loads growing, as you know, commercial loads going down. Industrial load have picked up. So I think from the utility sector, the impact has been a way to make sure that you can think, if we are not an old industry, we can innovate, we can change on a dime. Mm-hmm. And we will need to change very quickly, because it is clear all the stars and signs are now aligned that we will increase our pace towards a clean energy future considerably this decade. But we got to do that reliably and affordably. And for those of you in Texas, I think reliably, you know what reliably would mean.
Absolutely. Llewelyn, you want to piggyback on that and share your
Sure,
thoughts?
I would. Well, first of all, I'd like to add my thoughts to what Arshad said about it's not over as far as the pandemic.
Yep.
When an interconnected world has 2 countries where it is raging out of control, 2 highly populous countries, especially India. This is a global crisis in India. It is not an Indian crisis just in India, and it is going to affect the rest of the world, whether we like it or not. You also have, while the pandemic is raging, while COVID-19 is raging, you also have the possibility that it will mutate into something that is beyond the scope of our immunizations. It is very critical, and we cannot sit happily and say things are great in the US, things are not great while this is going on. I've been working this week and writing about and researching something that interests me and might just interest Arshad, and that is the use of low levels of radiation to deal with cases of COVID-19. It's a very old treatment. It was used for viral pneumonia until the better drugs came along to replace them. It also, as with nuclear everywhere, suffers from a lot of stigmatization, a lot of fear of radiation. In fact, the doses are very, very low. It's about 1/80th of what you would use for cancer. anyway, I've been hoping that the Indians, who have done some studies of low-level radiation, it's called low-dose radiotherapy, LDRT, will use their expertise. I just yesterday read a study done in India. It was a very small study, but a very promising one, where 10 patients were treated and, of course, survived, did not have to have supplemental oxygen, did not have to go on ventilators, and in 3 to 7 days could go home from the hospital without any of the normal excesses of the mechanical assault on the body, which the conventional treatments, I do hope that this can be a turning point both in the use of radiation in medicine or nuclear generally in medicine, but also might be the beginning, if it is adopted in any large way, to a better attitude to nuclear, which and I don't know what Arshad thinks about it, think is the fastest, easiest way to completely produce an electric source, a source of electricity that is green and stays green for a long time. The design life of most of the alternative energy structures, solar, wind is about 25 years. The nuclear plants have been licensed to 80 years and could go to 100 years. Seminal time, and this disease might have a small beneficial effect eventually. Meanwhile, it is an horrendous scar on the human race in the world today.
Mm-hmm. John?
Yes, Arshad, it's very interesting that you talked about the adaptability of humans, and how we talk about that here is business models. So given all the things that's happened and given what you see in all of your research, and we know what the profit centers have traditionally looked like in your industry, and you talk about all the great ideas that's coming out of the pandemic and all the research that's being done, what do you see as the new business models, the new profit centers that will come out of your industry that your research can provide new profit centers? But for the most part, Austin Energy, they provide services and they get paid. But given the smart city, have you thought about the different kinds of profit centers or the new ways of business models in your particular industry?
Yeah, I mean, we do. Our focus is on technology, but technology devoid of business model isn't applied. No, there are so many. First, step back and look at what are the 2 key things that will be driving this industry for quite a while, decades. One is we want to achieve a low carbon future, net zero. Another one is we want a system that's going to be more resilient, because societal dependence on electricity, when we start electrifying, is going to be a lot more. And if my power is out for 3 days, the impact in a 2040 family is very different than ours. Business model wise, I mean, I heard about nuclear from Llewelyn, and I think the largest source of carbon-free energy in the US is nuclear. Just look at the data. Worldwide, there are large plants that are being built. We haven't been too successful in building large plants over the last, but there are a couple of them coming online. What people misses about nuclear is the business model, because nuclear in many places is actually providing necessary medicine and sanitization. So nuclear medicine is a big thing. We are looking into nuclear, and not just nuclear, any clean generation source. If electricity is plentiful because the wind is blowing and the sun is shining, what do you do with that clean electricity? Maybe you're creating hydrogen, which is an energy carrier that one day may be a natural gas hydrogen combination. You could create liquid ammonia, which is what the aviation industry is depending on, decarbonization. So the biggest business model evolution for this industry that's going to happen in this decade is you got to look beyond electricity. You got to partner with the cement industry, because you may be producing the liquid ammonia from nitrogen and hydrogen, which is coming from clean electricity. You may be partnering with the telecom industry and addressing what COVID-19 has exposed, which is we have a huge digital divide. internet is not just for Netflix and other, watching movies. Internet is the way we work. Internet is the way we go to school. But look at what's happening in the disadvantaged communities. So if a utility has to do smart grid communication, can it not be a same communication infrastructure that does broadband? And business model will figure out how you allocate that, because then that's the only way. I would say that is the only way we address the digital divide, is the way we addressed the electricity divide in 1930, FDR, Rural Electrification Act. It made no sense to build a 100-mile line for 4 farmers. Cost benefit didn't work. But society made a clear, conscious decision. Electricity is a better form of energy, and it will light our life. We did that. So the opportunities for this industry to be the tip of the spear, not just to decarbonize our industry, the power sector. We are not fully decarbonized, but 60% of the emission is industries, buildings, transportation. Who's going to decarbonize those sectors? Mm-hmm. So I think that's the biggest business model. Electricity has to think beyond electricity. We joke, is EPRI Electric Power Research Institute or EPRI Energy and Power Research Institute. It's no longer a joke. We are heading towards an integrated energy network.
That's right.
But this is good. So what you're saying is, as your industry becomes the leading industry in the world for how we do work and how we go to school and how we move around, there's a cross-fertilization of ideas where products that's produced from other industries, right, can enhance other products from another industry. So the cross-fertilization, the circular cross-fertilization will continue to create new profit centers and new business models for your industry. So no longer, and I would like to say that my father was a county agent and he did rural electricity. I would like to say that. But I'm fascinated by the idea that we haven't, Andreas, really talked about the different kind of business models and the cross-fertilization of industries that will produce these business models. And I think it's absolutely wonderful. Thank you very much, sir.
Absolutely. So Mansoor, we as we track the digital transformation of industry here every week, we talk a lot about telecom, and you just brought up an interesting, proposition for utilities and regulators to take into consideration. In some states, many utilities are vertically integrated and they are the telecom provider as well and the internet provider. But in many places are not, and in many places it is banned for that to happen, like in Texas. But when we look at 5G and telecommunications and IoT, Internet of Things, and all these new technologies, LoRaWAN, NB-IoT, WirePass, Wi-Sun, to deal with the billions of devices at the edge of infrastructure. What's your take on the importance of this, knowing, for example, Apple is investing into the U.S., 20,000 jobs in the next 5 years, $430 billion impact into the U.S. economy. Crown Castle, raising the outlook, claiming, 5G frenzy in their Wall Street reports. Verizon is expanding all over the United States. Ericsson and Nokia building 5G networks everywhere at a pace that is unbelievable. What's your comment on the importance of telecom, 5G, IoT in the future of energy and electricity and power?
Well, I wish I could share what I was asked by our board of directors in one slide, what is EPRI strategic focus this decade? You can't put a lot of stuff for a $430 million annual research organization. And in that one slide, we put 2 pillars. Mm-hmm. Middle is the customer, always. Mm-hmm. Decarbonization and resiliency. Mm-hmm. But bridging those two was the digital transformation of the network and the power grid. Because without that, if we just do brute force resiliency and brute force, just bring in more wind and solar, we're not going to be able to achieve it, and forget about achieving it reliably and affordably. So digital transformation, it's easy to say. We have been digitally transforming the industry for a long time, but we are at an inflection point. The communication systems are becoming ubiquitous. Sensors are becoming ubiquitous. Machine learning and artificial intelligence is no longer just the privy of a few experts. It's now commoditized. And bringing all those together on the customer service side, on asset management side, on squeezing more, the nuclear uprating. We talk about nuclear may shut down because it's not competitive. Hopefully, one of the things that has happened with the administration's pledge to reduce emission by 50%, people are realizing it just doesn't make sense for 1,000 megawatt, 24/7 carbon-free energy source to be shutting down. But why can't we make that 1,000 megawatt 1,100? Uprating is, why can't we uprate the hydro plants? You got to do it digitally.
That's
You
right.
can't just do a brute force, I'm going to put another turbine. So I think the digital transformation, in a way, we are in our infancy. But the opportunity communication, look at the chip shortage we are having. We got to look at supply chain beyond our industry.
Yeah.
I mean, the chip shortage is happening in affecting every industry. It will impact our industry as well.
Yeah.
And that,
Absolutely.
if I can ask a question, is it true then that all of the technology to bring the grid up and digitize it is sitting on the shelf? That if you look at projects that people have, especially in my area of technology transfer, one of the arguments made is that we do tons and tons of research, but things sit on the shelf. And if we go to the grid edge, if we digitize everything, we know where every bit of electricity is. Is it true or not true that the technology to do that is sitting on the shelf in laboratories right now? And the big issue is to get the business side of the grid to move. So what people say is that the grid is doing well on the technology that they had. And like you said, it's been transforming for a lot of years. But can you imagine a grid that's digital? Much like we're where computers were, 60 years ago. But all of a sudden, as you said, to get this transformation, everything is digital. So my question is, am I wrong to say that given all of the digitation stuff that we have in other industries that is sitting on the shelf, but the business models, and this is an industry that moves like a glacier. So the question is, how do you get the industry to pick it up, to digitize things much faster?
Well, that's actually going back to nuclear. You would think the digitalization of nuclear was done 30 years ago. We're actually now starting to do that. One reason, though, we got to all be acknowledging that electricity is, that's how our life runs. If we don't have it, we know what it means. So unlike my iPhone, which I love, and every month I'm getting updates, if something doesn't work, they'll send a version 6.9.2.4.
Right.
You cannot afford that either in a nuclear plant or in 5 million smart meters. But we have now deployed the smart meter, the whole, we call it DER, Distributed Energy Resource Aware Grid. A DER dependent grid has to have extremities, grid edge and communication. DERMS, Distributed Energy Resource Management System, exist. I would just caution, they exist, they work. But think about SCADA in 1965, because that's where it is. It's the dawn of this. And you have to also recognize the role that a public utility commission plays in an industry that has a really societal mission. They are the provider of the last resort. They have to provide electricity to whoever wants it. And the public utility commissions are very, very careful and prudent about making investments in unproven things. But we are seeing, as part of EPRI, we engage with NARUC, which are the commissioners. And clearly everybody realizes in order to get to net zero, and in order to do that resiliently, there is no other way but for us to completely embrace a digital transformation.
Right. Llewelyn?
Well, I'd like to ask Arshad about the security of the grid. Constantly, the grid is under attack by state players, by adventurers, by amateurs. And there's a general concession that a huge amount of effort is being put into the IT protection of the grid. But I'm told that there is less attention to the operating technology. And there is a school of thought which thinks that there is huge vulnerability to the electric sector in operating technology, in the controllers that run things, the logical controllers, and that they are vulnerable largely because of sensors and other backdoors built into bulk electrical equipment, which was not constructed in this country, but most usually in China. Does that worry you? Is it a real problem? It looks, on paper at least, to be an horrendous problem.
It is. I would say it's not. It's one of the biggest risks that industries have to make sure they have prudent methods to minimize that risk. It's the water industries, the gas industries, the airlines industry. It is, imagine your electric car. I have an electric car. Softwares get updated through the air every week. Imagine somebody, and that's OT, that's operational telecom, when somebody is updating a software in your car. Imagine if somebody could intrude and change the autopilot feature. And all of a sudden, one morning, 5 million cars have a bug that will make it. So it's not just the electric grid, it's the entire ecosystem of grid edge, sensor-driven data analytics and communication that will need to continue to evolve. But where I see cyber, and I see the positive side of it, is imagine we now have digitization, which means a lot of attack surface across the grid. I can reconfigure the grid much more quickly and actually minimize the impact of a cyber event. I could have distributed energy resources working in conjunction with central resources, and I could get flexibility on how I reroute power. But you are absolutely right. We have focused a lot on what we call IT security. That's your servers and database. We are focusing a lot on OT security. We saw on the IT side what happened several months ago. In the OT side, I think we have to be even more vigilant. I would say go to Google and Google EPRI OT security. And that's where we are putting most of our focus, is the millions of devices and relays and sensors that will become digitized soon.
Right. There are not short about 200 transformers, some of them very large. And there's the strange matter of the one that was destined for the Washington Area Power Administration and which was seized by the government and taken to the Sandia National Laboratory, and nothing has been heard. What's that about? What did they find when they pulled it apart? When I asked DOE, they say no comment. When I ask EEI, they say no comment. When you say no comment to a journalist, they usually think there's quite a bit of fire behind that smoke.
Well, no comment is a good thing to say because that these are confidential. These have different layers of information that we don't want to get out. But let's step back on that one event and see what the real issue is. The real issue is supply chain security. And supply chain security, whether it's the large transformer, which will have digital relays, or if it's supply chain security for our server, for our relays, for our sensors, we have to continue to get better on supply chain security. I give this example. Ask Apple on their iPhone. They know exactly each microcircuit, who made it, when it was made, when did it move from one place to another. It's tagged, it's recorded, it's completely there. Ask a relay manufacturer, what is in your relay? Who made it? Who did the software? How did it change hand from one place to another? We're not there yet. You can ask Walmart on how the lettuce moved from 1,000 miles away farm to your Walmart grocery store. And they're using blockchain to track every handoff and every transaction to make sure that they stay authentic. We have, again, technology will be the way. You can't 100% protect If anybody says we are 100% protected against cyber, that's not going to happen. But look at a DER-aware grid that can reconfigure on the fly, both on the distribution and transmission side. That's a pretty robust grid that has a better ability to survive an event. And hopefully that never happens, but hope is not a strategy.
Yeah.
Yeah.
Let me get your take on some new good things that are happening, right? So DOE is offering today $8 billion in transmission loans for clean energy projects across the nation. Elon Musk touts Tesla's move to sell bundle home solar panels and energy storage, power walls. We have the 2.3 trillion bill that has $100 billion for a smart grid, $174 billion for EVs, $10 billion for conservation jobs, $200 billion for research and other clean tech items. I mean, it seems like we're about to hit abundance. What are your thoughts on where we're heading? What's happening to the battle against climate change and the resources coming?
Clearly, the industry was already unified. In the last 3 years, most of the US industry power side have come up with the net zero pledge. Now the federal government has done that. I think moving to this net zero world will require a supercharge is not even the right word. It's more than supercharging innovation. And we see great signs now, only we don't know how many it will be effective, but let me give you one example. You mentioned DOE. Department of Energy is one of the most influential, federal organization. They would be at the tip of the spear. White House announced in one of their communications just last week that the Department of Energy will partner with Electric Power Research Institute, EPRI, to develop the interoperability guideline and distribution planning guideline for fleet charging. Mm-hmm. Because on electric transportation, you will see a huge move towards transit bus, places where the underserved community really will benefit from electrification. And working with Department of Energy, bringing in hundreds of utilities together. If you're going to do school bus electrification, and I don't know how many school systems are there in the US, but let's just say 5,000 as a number.
14,000.
14,000, we were in the right. So each school system will have to work with their utility and figure out how the charging infrastructure will work. Can I do V2G? Mm-hmm. Why can't DOE and EPRI and the utilities and EEI and the trades, APP and NRIC, we all team together, mm-hmm. create a center of excellence, mm-hmm. so that any school system and any local utility, co-op, so we see the opportunity limitless. Mm-hmm. We have to be focusing on not everything. And the two areas that we are focusing a lot on is electrification of transportation. Mm-hmm. And the other area where innovation is absolutely essential this decade is, before this decade is out, we need to figure out how to affordably decarbonize the steel sector, the shipping sector, the natural gas sector, mm-hmm. the airline sector. That's the hydrogen, liquid ammonia, renewable gas. Mm-hmm. It's not going to happen in 5 years, mm-hmm. but the research needs to happen in the next 5 to 10 years, so that beyond 2030, after we have reduced 50%, let's just be optimistic, we have reduced global economy-wide emission by 50%, 6 gigaton 2005 to 3 gigaton in 2030. That's 50%. How do I take that 3 to 0?
Right.
The technology to get there, advanced nuclear. US had the leadership in large nuclear. We hopefully will get that again, but instead of getting that again, US can be the leader for the next generation, reimagine a nuclear plant that's not just flexible, mm-hmm. that's not just small, mm-hmm. but it's safer. And a high temperature reactor could produce hydrogen when electricity is not needed. That's so right. US can again take the leadership role for the next generation reactors. Doesn't have to be advanced light water reactor. Mm-hmm. It could be molten salt, it could be others. And nuclear is the largest part of EPRI's research. 80% of nuclear power plant owners in the world is a member of EPRI. So carbon-free energy source and nuclear, those two goes very well. Wind and solar will have a huge impact. We got to make a difference on carbon capture and storage. I would say EPRI and to some extent the industry. We dropped the ball in the last 5 to 10 years because we found natural gas can reduce emission by converting coal to gas. But at some point, what do? You've converted most of your coal to gas. You have to make carbon capture and storage, both from a regulatory point of view and cost point of view working. So those are just the innovation things that just excites us. And it's not EPRI. This is so huge. It's not even national labs. It's national labs, EPRI, but needs to be done a bit more coordinated way though. Otherwise, lessons learned will not be shared.
Yeah.
Well, let me ask you this, sir. I think that it's very, very interesting because you're describing an infrastructure, a complete interaction between the research and the infrastructure. And during my lifetime, during presidential debates and gubernatorial debates, we don't have electricity at the very, very center of the debate. So my question is, what I want to do is turn on my lights and they'll come on and make sure that when I need it, it is there. So given that you're describing the interaction between industries, how do you get the political insight, the consciousness of politicians and the consciousness of people themselves to understand that the new world that we're moving in, that electricity has always been at the center, but it is really at the center now. There are no debates on the things that we've talked about during presidential election. There are no debates. Now in Texas, we like oil and gas. We might have to beat you boys and girls back and continue to drive in our combustion cars. No, seriously. So my question is, what do you do to change the consciousness of the political process? Because we just want the lights to come on in the Capitol.
Well, and lights needs to come on a lot more. I think talking about electricity as a center, just some numbers. In US, 20% of the energy that we use in our homes and cars and places, only 20% is electric. 80% is non-electric. That's natural gas, heating oil, petroleum. Right. So if you look at, and it took us 130 years when Edison and Westinghouse were duking out light bulbs in the Chicago World Fair in 1880, I think. From that 0% to 20% in 120 years, 140 years actually. Mm-hmm. We have to go from 20 to 40 or 50 in the next 30 years. There's no way. And this is where at least you have unanimity in scientific consensus. You cannot get to even 50% reduction, forget about net zero, unless you electrify. Not direct electrification. You don't electrify a 747 flying from LA to Sydney. What you do is clean electricity produces the liquid fuel. So I think politicians and stakeholders, all of us will change. Look at how Shell is changing. Look at how ExxonMobil is changing. Look at where they're making the investments. And look at where BP just registered as a power producer. Because everybody sees the electricity world as the world we will get into, either directly, which is direct electrification, or indirectly, which is electricity creating another energy product. Mm-hmm. The next generation fuel that would be carbon free. And so I feel that there's no other way. What do you do with the airlines industry, shipping industry, cement industry? I can go on and on and on. It's just the reality. So it is one of the most exciting time. Our CEOs, our industry executives, but they know that if you don't keep your eyes on, make sure that the lights are on when you flip the switch, nothing is going to happen. Mm-hmm. The resiliency of the grid will be the biggest obstacle to achieving a net zero. Not wind or solar or getting more nuclear will get there.
Let's find some Nikola Tesla's work, because you sound just like him when I read his work from when he lit the World's Fair in Chicago. Yep. And he said there should be enough energy somewhere out there to electrify the entire world.
Yeah. Let me pause real quick. I'm going to come back. Let me take 15 seconds to tell everybody about our annual conference and thank our sponsors for the hour. Hopefully you can see my screen. So the Digital 360 Summit is coming up August 31st through September 2nd. And we are packing a phenomenal event. And I want to officially extend an invitation for Arshad to join us, if he would be kind enough and time willing to deliver a keynote for our event. We'll circle back with you, Arshad. Don't want to put you on the spot. You haven't looked at your calendar. Don't even know if you're available. But I just wanted to share that with you. And this were the speakers in our last conference. Obviously, John and Llewelyn were there, and they'll be there again this coming year. And I want to thank Texas State University, where I'm a professor and director of the CIEDAR Consortium, the Connected Infrastructure Consortium, building all kinds of labs in leveraging the 1,800 PhDs and the 40,000 students for sponsoring our wonderful digital roundtable. So let me circle back real quick and Llewelyn, park your, if you had a follow-up question or anything. I wanna basically, there were two elements and you brought them already up, Arshad. You talked about, you know, the other sort of sectors where decarbonization needs to take place and they're harder to figure it out. Buildings. There's another trend, and I know that, you know, giving you a softball here to easy to hit. You know, smart buildings, connected buildings, they are customers of the utility in electrification, right? And one of the things that I wrote about in 2011 in my the Advanced Smart Grid book, that was this notion of positive energy buildings that we came out and started talking about it. And so we have 145 million homes, 28 million commercial industrial buildings in the US. And somehow turning them into power plants will be a great sense. We'd love to hear your thoughts on that and what's being done. And then this whole trend of smart cities, right? Cities are kind of this umbrella concept of digitizing all kinds of things from parks to everything in between that fits, you know, hits again buildings and obviously mobility and transit and all these things. What are your thoughts about how EPRI and the electric sector is impacting and driving buildings and smart cities?
I think right now where we are, I would say I would classify the US distribution system with smart meters and all those things, but we are still very few penetration of distributed energy resources. So it's almost like DER agnostic. The grid will work, but for DER to grow, for buildings to be self-sufficient or generating power, you cannot, and that's the biggest business model issue again, is you can't have 1,000 different manufacturers having 1,000 different pathways. There needs to be an integrator. There needs to be not just awareness of where all these DERs are, but imagine we go from a DER agnostic grid to a DER dependent grid. The DSO, distribution system operator, their life just completely changes. You can't do that without complete digitalization of the grid. It will require investments. It will require public utility commissions to take the leap of faith that a DER dependent grid in the long term will save money for the society, but in the near term, it's going to cost more money. It's like the same 1930. It's going to take money to build a 100-mile line to serve 6 farms. But in the long term, electricity. So we're coming to a point on 2 areas, and the other is electrification of transportation. Who is going to put charging infrastructure where the underserved communities are? Who's going to put charging in? We have more cars than people. So an average US family of 4, $40,000 with 2 cars. They do have 2 cars. You think Tesla or other organizations will actually build charging infrastructure in that neighborhood? They just go and look at where the Tesla charging infrastructures are today. So you have to do that. You have to build it. Building it societally like we did the electric sector is most likely the best approach. And then you can integrate all the charging networks so you can send smart charging. It's a journey that is so profound for the change of the electric sector
Mhm.
I think we have been talking about it for some time, but now you got the convergence of we got to go to net zero by 2050.
Yeah, yeah.
And
Two points that I want you to teach to our audience listening. Two points that there's always a lot of confusion because people are not, electrical engineers, PhDs like you, and don't know physics and things. But a couple of points to make real quick. So describe real quick the transformation of taking a bus yard for a school that has 100 buses that is sitting at the end of some, distribution line with regular electricity to a facility, and now all of a sudden they want to go fast charging for 100 buses. What is that? What needs to be added to that little yard transformer to turn that into that?
well, FedEx would love that answer because FedEx, UPS, they're all. This is where you can't do it in brute force. Brute force would be, I'll build a brand new transmission line. I'll dump in a 50 MVA substation. And you still will need to build transmission line. You still will need to upgrade your distribution. You still most likely may need to upgrade your substation, but do it in a smart way. What does a smart way means? Maybe the utility works with the Public Utility Commission and all the technology providers and set up a microgrid with storage that can help the utility to be more resilient, but could also provide the power that a humongous 100-bus charging station would need. So not all the power is just coming from the utility. You could actually, people are thinking, why can't I use electricity to make hydrogen? And some of the buses could be hydrogen. So that if a storm happens and I'm out of power for 2 days, hopefully not in 2040, Walmart still has to run those trucks. If it's all electric, and you're going to have a battery backup in the yard, why keep a battery backup on the yard? Why can't the utility put a big battery that has a dual purpose?
Right.
So another business model change, John, that I think is very profound is we call it the sharing economy. The sharing economy, Airbnb, Uber, is I've got something, a house, and I've got a room that I don't need, but somebody else is needing. So think about a battery in that bus yard. Well, the battery could charge the buses, but the battery could also have another need, which is grid reliability and resiliency. So you could have products that a bus depot manufacturer could get from a utility. And the utility would say, hey, you can use this battery for charging 5-10 times a year. We may need it for the grid.
Right.
And that's one asset that has two clear value streams.
Right.
And you can take this thing forward to why can't a utility, regulated utility, put a battery at the meter?
Right.
So it's a resiliency. Imagine the Texas, the people in Texas.
Yeah.
Somebody, they would buy solar and go out and just take that little bit just to thaw some ice.
Yep.
So I think the opportunities are huge. Business model, regulatory side would be as much of a challenge as technology.
That's another second and last question, and I'll circle back to the guys to help us tell the audience understand. And again, as an expert, so a lot of people talk about we want to go green, we want to go green, we want to go green. So I'm going to ask you just quick answer. So if we wanted to go green, do we have the technology today to be 100% green 24/7, 365 if we remove nuclear, coal, and natural gas? Could we be green tomorrow morning if we decommission all the load, all the base load?
If you want to be green and your lights to go out, and if you want to be green and paying maybe 8 times more, and even then, tomorrow it's not going to happen. It may take 10, 15 years for the grid to evolve for that scenario. But why would it go to that scenario when there are better ways to reduce greenhouse gases?
Yeah.
So, is it possible to put enough solar array in one state, Arizona, and power the entire United States? Yeah, in the math, it's possible. But why would you do that? the amount of transmission. I mean, so practicality and feasibility of a solution is important as can technically we do that.
Got it. Guys, any follow-up?
Yeah, I do, if I may. Arshad, do we have any ideas for storage beyond hydrogen, long-term storage? Batteries have a limit because they're quick drawdown. We need long-term storage that can be utilized over, say, the 90 hours. That was the length of the freeze in Texas. Any hope for storage besides hydrogen, which is a bridge far away?
Well, we have 30 gigawatt of storage called pumped hydro. It's difficult to build a brand new pumped hydro, but let's operate all our hydro. You could through digital technologies and innovation, you could operate the existing hydro and get 10%, 15% more power. I am a big fan of compressed air energy storage. EPRI was involved in the first plant that we ever built in US in Alabama, where there is enough geological foundation in US to compress air and store and use that air back again to generate electricity. So that's another large scale storage beyond hydrogen. Hydrogen it's a bridge too far. But if you look at the technical opportunities, imagine we have 3 months worth of natural gas, I think even more gas storage in this country. No reason why those storage cannot store hydrogen. They're already there. Sure. They're porous rock, they're airtight. So it's possible our natural gas economy moves towards a hydrogen renewable gas economy, but it's a bridge long. It's not 2030. It's a longer, it's 2050.
I'd like to follow up, Arshad, and ask you about your discussion of charging stations. Is that the responsibility at all of utilities? Surely that's a collateral development which business itself will find ways of making money at and provide far better than if utilities try to provide it. The analogy would be, build the airplanes, don't try to build the radar, somebody else will do that. Are we not trying too much planning? I remember with nuclear, where indeed a predecessor of yours, Chauncey Starr, had this very elaborate nuclear plan. Don't worry about waste. It's going in salt caverns in Lyons, Kansas, except they found they leaked. We're going to have light water reactors, followed by breeder reactors, followed by fusion reactors, in a straight line of industrial planning, except industrial planning has its limits. Shouldn't we decide which part of the vast business of charging, very appealing business, a nice business like dry cleaning, high profit possibly, small operator possibly, shouldn't that be left to a new generation of entrepreneurs with the raw material, the electricity, being provided by the utilities in the traditional way?
Well, that will take a long time, but short answer is that should not be the way we approach this. Just like we didn't approach rural electrification just by relying on private companies, because you will only build charging infrastructure where you can make money.
Yeah.
And the people who would be most beneficial, and I don't know why we don't talk about it. An average $45,000 household that I mentioned, their energy bill is $4,500, gasoline, electric, natural gas. If they can switch both their cars, imagine the cars are now at equal price of gasoline car, their energy bill goes down $1,000 from $4,500 to $3,500. Yes, the electric bill goes up. That's $1,000 stimulus for that average US household year over year. And they're not going to be able to do this unless charging infrastructure is in their neighborhood. And who better, transformers are not made by utilities, poles are not made by utilities, distribution energy resource management system, DERMS are not made by utilities, smart meters are not made by utilities. There is innovation from everywhere. But the utilities supply that, they deploy it, they manage it for 30, 40, 50 years, and they take the full network value. Because if otherwise what you will have, and we have it right now, You go to a gas station, what do you need? Credit card, debit card, money. 3 things. Go to an EV charging station. There will be some EV charging station that only will charge your Tesla. There are other charging stations where you have to have a dongle for that specific. You don't want electrification of transportation where there are 500 different charging networks without interoperability, without standardization, without a comprehensive integrated loop. So I would say that should not be the way we move forward on electrifying transportation.
I would say that what you need is a federal standard. You don't need a federal purveyor, and you don't need an institutional purveyor of the electric utility industry. You need a standard, and then let the pieces fall where they may, which is how we've done many things, including the internet itself. It's the standards that make the internet work. It is not the internet, many players on the internet. It seems to me that the great thing about the capitalist system is that it is only, to a certain extent, a system at all. In many ways, it's the lack of a system which gives it its unique energy and innovation capacity.
Yeah.
2 socialists in the 19th century arguing, Bernard Shaw and H.G. Wells, about this. And Wells thought that capitalism would fail because it didn't have a system. And I think he was countered by Shaw, but I'm not certain it was Shaw, who said, no, it's working because it's a lack of system. And I wonder if you have this much planning, this much intention to deploy, whether this is really going to work that way.
One answer, internet. So why do we still have a digital divide? Significant digital divide. Why? Because it doesn't make sense to bring money. So internet is standardized. IPv4, IPv6, internet is standardized.
I'm all for standardization. I'm just for diversified ownership and endeavor.
Absolutely. Absolutely. The ownership has to be diversified.
Johnny?
Yeah, let me see if I can get this together. I think what he's saying here is that
Oh, my dear boy, I already had it together.
I think what he's saying here is that, look, there are dry places in cities where there are no supermarkets. There are dry places in cities where you can't get gas. But there are also schools in all of those areas. And without the highway, so you look at it as a highway, then it cannot exist. That is, there must be something done, right? We could do without a supermarket, and you could drive to a supermarket, but we cannot do without charging buses because they need the buses to go. So therefore, when you rank things in terms of what is needed, the highway is needed to go everywhere. And of course, this is needed more so than the internet so that people can go everywhere. Because without charging, then there's no way to get where you need to go. So all of a sudden, of course, you have a situation where a private enterprise would say, I'm not going to put a charging station there because there's no returns. And so I think that it's much more than a divide. It is the reality of how we move forward, because everybody needs to drink water. Everybody needs to have air. So this is a commodity, if you will, that is needed by everybody just to put us in motion in vehicles.
That's right.
I know that my distinguished colleague had it together, but I just wanted to clarify his distinction.
Oh, that's perfect.
Indubitably.
The closing question that perhaps puts a wrapper on this, on where these players are coming from. Clearly, we have a significant number of incumbents,
Yes.
Existing powerhouses, the Schneider Electrics, the Siemens, the GEs, the Eatons of the world, and the like. There are key players, ABB, Hitachi, ABB now, so on and so on. And then you got, our infrastructure of electric utilities and so on, government owned and private and so on. But Arshad, I'm curious, what do you think Order 2222 and 841 around DER in allowing for aggregators to emerge, perhaps companies like Google or Amazon or Verizon or AT&T? What do you think is going to happen as the ISOs, move forward with the implementation of Order 2222 and 841? Is this a new Pandora box that brings in a lot of players that could play? What's going to happen?
It should bring in a lot of players. It should bring in Google. It should bring in all the players. But it also needs to make sure it is fully integrated. And that integration has to be done by the organization that is running the distribution grid, which means sensors needs to be everywhere at the grid edge. Control and communication needs to be there. So I don't see as an either or capitalist or socialist thing. I see for the common good, it needs to be integrated, but innovations should thrive on the edges, because we are embarking in a decade, and this decade is not going to end just this, next 20, 30 years. The two biggest industrial sector that will see a profound change, and they're actually getting together. We call it Network or Electrinet. Electricity network. Electricity and telecommunication. Electricity and communication, they together, both those, the reason you see 5G, the reason you see all the work going on, shortage of chip. And then you look at electricity, that's the power to decarbonize cement, shipping, airlines, all this industry. Those are the two industries that you would see in the next 10, 20, 30 years have a profound impact in our life, a whole lot more than electricity already have had over the last 100 years.
Yeah. Well, thank you. Thank you for that, those remarks and your insights and your wonderful analogies to help us understand the challenges in front of us, but more importantly, the opportunities. Who would have thought that working on energy would be so exciting today? And I am so proud and happy of my choice of moving to Texas to actually tackle this industry. Any parting thoughts, Arshad, as we wrap up today?
It has been a privilege to interact with three luminaries. So it's been a full privilege for me.
It's been a great pleasure to be with you, Arshad. And I don't think no comment is ever an acceptable answer, ever.
It is always great to interact with Longhorns. We're changing the world. Looking great places to do so. I would like to say that I would probably have you as a guest speaker in my MBA class on innovation and technology. But as we say at Texas, and maybe they might say this at Brown also, I'm not sure. But what starts here changes the world. We're proud of you. Welcome home and continue to do great things. And what a great position you have been elected to. Because remember, although you are in Washington, D.C., the Syndicate of Energy is Texas.
You got the last word.
Thank you, gentlemen. Thank you for a great program today, Arshad. Thank you very much. All the best.
Thank you.
Thank you.
Johnny, send us away with music.
You get the feeling all alone when your good time friends have all got up and gone. Just come knocking around my door because I've heard your tones before. There ain't gonna be a next time, this time, starting right now. I'm gonna forget your name and your pretty face and write you off as a bad disgrace.
Bravo.
Bravo.